Good day, everyone. Welcome to Actian 2021 Hybrid Data Conference. Firstly, I would like to thank everyone for taking the time to attend this Actian Hybrid Data Conference to learn more about what we do at Actian and what we can do for you. In this track, you will learn why Actian is purposefully built for the demands of edge computing, and if you stay till the third session, you will get to hear the exciting partnership Actian has with Intel in making meeting the needs of edge computing demands as easy as riding a bicycle. Before I begin, here is our standard disclaimer. Everything I present today is as it stands today, but that could change, and that change could be based on your input, our customer, and partners. So here we go. What is edge computing? Edge computing, in a nutshell, is this diagram on the left. Effectively, edge computing allows data from edge devices to be analyzed at the edge of the network before being sent to a data center or cloud data warehouse. So you ask, why is edge processing needed? As you can see on the left, edge processing is being driven by the following three drivers. 1. Latency. 2. Bandwidth. 3. Data privacy plus data protection. What is latency? The dawn of edge computing started with what we cannot let go today, our mobile phones. And with technology advancement, a computing device can be as small as a pack of gum. As more and more smart devices are added around us, some of which we wear on our wrist, the quicker we expect feedback from these devices, and the quicker we expect these devices to do what it is designed to do. As you can see on this slide, as we move towards the left, the latency expectation gets shorter. We are okay with cloud traffic taking approximately 100 milliseconds, but at the device or things end, feedback needs to be almost instantaneous. Bandwidth. This is like a chicken and egg situation. Did more bandwidth create more devices being added? Or more devices create the need for more bandwidth? This is an interesting paradox. Technology advance has brought us larger bandwidth like 5G, but because it is readily available, solution providers get lazy. Hence, load size optimization is all forgotten. It is a rat race. More bandwidth means more data can be pushed through. So why be conservative? Imagine if today we are still using our dial-up 56 kilobytes per second modems. I can bet the web pages we see today will not be as rich or loaded with advertising. By 2022, it is estimated that 82% of IP traffic will be video content. Does it make sense to move all this content to the cloud? Edge computing will also push service providers to rethink their businesses. By processing data at the edge, can they reduce costs, improve quality, and create new revenue with value-added services such as content delivery networks? Cloud gaming, or video analytics for enhanced retail. I bet all of us want to be reminded that in the store, besides buying beer, we are really there to buy diapers. Data privacy plus data security. Through 2021, it is estimated that 50% of organizations that are subjected to general data protection regulation will suffer from a lack of governance and visibility into mobile workflows. Data at the edge will become more personally intimate. Data like personal health, facial, or voice recognition data. Data interactions in private locations, or confidential and critical internal data in a plant will make data privacy and security a very important aspect in data management. Edge computing will be used to address growing regulatory requirements and privacy by processing, storing, and discarding data in place. It is better to process and discard data at the edge, and to move only what is necessary to the cloud. It is not just for security reasons, but for cost control and data sovereignty. By 2022, IoT security attacks due to lack of insight into the edge will increase by 35%. Each point of data manipulation and movement between devices, gateways, the cloud, or the data center introduce a new attack surface and point of infiltration and exfiltration of data. Oops. And now you're asking, why did we create this mess that is driving the need for edge computing? The use cases are plentiful. Look at today's evolution of autonomous vehicles. Data must be processed on the vehicle, which is the edge for the vehicle to operate, to react quickly to what is happening on the road. Augmented reality and virtual reality that needs to create seamless experience to prevent users from getting motion sickness requires 15 to 20 milliseconds response time. Predictive maintenance. Can I prevent a failure from happening before it is too late that could affect my production? Our homes are getting smarter too. In fact, there are also talks about how to make our cities smarter. Smart metering that can enable better grid management, water management. Ask a Texan why this is important. Although I'm not exactly 100% Texan, I live in Austin, Texas, and survived our most recent winter storm, so I welcome that question. All these use cases require data to be processed at the edge, because besides improving our quality of lives, reducing costs, many of these use cases exist for safety and quality control. And in certain environments, a delayed response can be dangerous that could result in damages or loss of life. As mentioned in slide 6, service providers are being challenged. How do they create a new ecosystem? An application using technology that is available hardware and software-wise. How can we disrupt all industry in ways unimaginable? These slides present to you the template that can be overlaid onto any industry. Multi-access edge computing will be the epicenter of innovation. No longer we are talking about just wholesale moving of data to centralized data cloud warehouse. Multi-access edge computing augments and expands the possibility of centralized hyperscale cloud model. It answers the classic question of what goes where by encouraging placement of workload and capacity that optimizes the best balance of latency, bandwidth, autonomy, and security across the many options from hyper cloud data center to a thermostat in the house. This new paradigm does not compete or reduce the need for cloud computing. It complements and completes it. It enables the evolution and deployment of next generation digital business application. And now you will be asking, what should my data solution look like in a multi-edge computing environment? Today's great data center data management solution do not necessarily fit in the embedded space or meet the latency requirement. Enterprise databases are seen as overkill, expensive, and not something a developer can directly embed in their application. Consequently, developers start out with flat files using simple file read and write statements. As the complexity of the application increases, many develop incremental functionalities mimicking part or all of what they would have gotten from a database. Some developers might just face the fact that they might as well use a database. Often they opt for something that's stripped down and free like SQLite, poorly performing, limited to no data sharing. The other route is to buy proprietary but fully supported historian. This also has drawbacks, including limited functionality, interoperability with other tools, and expensive both upfront and over time. In many cases, when they need to expand the network resulting in supporting more devices in the grid, maybe adding a gateway or enable remote branch connectivity that results in the need for supporting a variety of data types, now the developer is faced with multiple architectures of databases to consider. each with their own architectural advantages and limitations. For example, some are touted for superior JSON support, as would be the case for document stores. Others, the ability to handle time series format. Others, the ability to handle back-end reporting, out-of-order transaction, and other functions best handled by a SQL database. Various reviews and a desire to approach everything as a fit-for-purpose build and best of breed can lead to database sprawl, with several different databases leading to further fragmentation and sprawl with all the added integration costs, security risks, increased procurement, and support costs. Let us look at an architectural diagram that represents the needs of edge computing in a manufacturing plant. You have machines with predictive maintenance logic, handheld devices used by supervisor to get real-time data insight, gateways collecting and aggregating data to be sent to a server sitting in a control room to observe the overall health of the plant. I present a high integration cost, high complexity, and possibly low security solution. Flat files or historian on the machines, SQLite on the handheld, MySQL on the gateway, and MS SQL on the server in the data room. Extraction, transformation, and load of data is required to move the data from one point to another. The need to perform ETL means overhead. It adds latency, it adds complexity to the app development because of the diverse technology used. Code logic must change if data changes, and data must be decrypted and re-encrypted to be stored in the destination database. Effectively, it is the picture explaining slide 10. Although multi-edge computing is no doubt the driving force behind the evolution and deployment of next-generation digital business application, it also presents the challenges that could be expected where data lifecycle and data types are different. A well-designed application can handle the workload and capacity that optimizes the best balance of latency, bandwidth, autonomy, and security across the environment. Multi-access edge computing innovation brings today cloud architecture and software development, and combine that onto the edge devices, edge gateways, maybe high-end complex equipment. It demands application and data management to be containerized. It is expected to leverage Kubernetes, Helm charts, RESTful APIs, etc. Edge devices and gateways will require application or data management solution to run on bare metal, real-time, or stripped-down operating systems. The best possible solution would run across different hardware, platforms, and operating systems, or environment agnostic with respect to virtualization, operating systems, programming language, etc. Data management solution needs to support application with NoSQL API and standard SQL. Platform agnostic data storage format that reduces the need for data transformation, and data needs to be encrypted at rest and in transit to eliminate and avoid attack vectors. By now, you most likely guessed that I will be presenting the perfect solution to address your multi-access edge computing data management requirements. I present to you Zen, your friendly neighborhood zero database admin, embeddable nano footprint edge database. Zen provides both NoSQL API and SQL access to your data. The API access provides super fast direct access to your data that meets the latency requirements on the edge. The NC SQL 92 compliant access allows your data to be accessed to be presented on business intelligence tool like Tableau or Qlik. Application written using the NoSQL API or SQL accesses the same data file. Data structured for fast speed access on the edge can be replicated and enhanced with SQL metadata to support data analytics and visualization. The data format is designed to be platform agnostic. Data created using Zen Core on your phone can be easily replicated across different computing devices to be accessed by any of the other Zen family of products. The data can stay encrypted at rest and in transit. Your data is protected across any of the computing devices used in the environment. You can design your application to have local unshared data, or to a full-blown multi-access shared data environment like a peer-to-peer or a client-server environment. It can also support your needs for data analysis in a separate compute and storage architecture. And did I mention multi-platform? Zen enables you to have deployment flexibility. Write your application in your language of choice: C, C++, Java, Python, etc. If your application is written to support multiple operating systems, Zen has the ability to support this multiple operating system. You name it: Windows, Linux, Raspberry, Mac OS, iOS, Android. What if you need your application to run on both ARM and Intel CPU? Zen has you covered. What if you need to store different data types because the gateway is collecting data from different edge devices? Again, Zen has you covered. Be it transactional data like point of sale data, JSON, time series, videos, images, or sound files. All this data can be easily stored in Zen. And if you're up to the challenge, you can store all this different data in one Zen data file. Now, if we take the architectural diagram in slide 11, the mess, and replace it with Zen, which we can because Zen can support both ARM and Intel-based hardware, and it can run on multiple operating systems. Zen Database Common Data Store format allows the data to be ported across the different computing devices without the need for transformation, and data can stay encrypted both at rest and in transit. For example, a data file created using Zen Core on the phone can be read by Zen Edge on the Raspberry Pi and on Zen Server on the desktop with no transformation. This greatly reduces the overhead of moving edge data through the enterprise. It reduces the vector for security attacks. Without extraction, transformation, and loading of data across different databases, it means improved performance and reduced vendor costs. And when the application is deployed, the Zero Database Administration Zen database will help reduce support and maintenance costs. It will simplify the application design, development, testing, and deployment. The application can now support both discrete and distributed environment using both the API and SQL. Your focus will be designing the best of world application and not worry about the data management in such complex environments. You might ask, what is this family of Zen products? You can view Zen as a single architected database engine that is designed to run on multitudes of environments. Effectively, it can be viewed as a family of products that provides a single data storage platform. However, it can also be sliced and diced, as it also provides several packaging options that should be considered as the evaluation of how the architect fits within any given project or product undertaken. Here we provide examples of where each version makes the most sense. Take for example, if a handheld device, the smart application needs an embedded database to be linked in and running with the application in a single process, then Zen Core would be the choice. If this smart application requires downloading content from other devices like a gateway or a server, then Zen Edge or Enterprise would fit to service these download devices on the gateway. Effectively, which Zen engine use is dependent on what you decide as best fit for the workload and capacity that optimizes the best balance of latency, bandwidth, autonomy, and security across the environment. However, these are guidelines. I would encourage you to work with us on evaluating your use case. So What does this mean to your business? As mentioned in slide 9, multi-access edge computing is the epicenter of innovation. This would mean new or existing business challenges, new or enhanced application that needs nano-footprint databases with full SQL and NoSQL, accessing terabytes of data at blazing speed for real-time responses. It might need you to support multiple hardware or operating systems. Zen flexibility places real-time data processing and analytics at device, gateways, or any other edge platform. It removes the data management from architectural fights over which hardware, platform, operating system, language, or any other tools to use. And it maintains the most important aspect of distributed data, which is data privacy and data security. Using Zen as the single edge data management solution has several benefits. It reduces database sprawl, cost of procurement and maintenance, reduces integration costs, speed time to deployment, and improves security at the edge. And I believe I missed a slide right here. At this point, you might be wondering, if Zen is jack of all trades, could this be a trade-off in terms of performance? I can assure you that Zen is not lacking in the performance department. To prove that Zen is not just capable of storing any type of edge data that could be imagined, we engaged a third-party performance testing vendor to make sure that Zen can stand up to the performance challenges. The first one being InfluxDB, an industry-recognized time series database. We put Zen and Influx to the test. The hardware used is a simple Raspberry Pi and the application written using Influx API and Zen API. Zen outperformed Influx on inserts by 38 times and 25 times on queries of 2,000 data points. At Actian, we do not rest just because we are faster than Influx. We put Zen against Couchbase, another industry-recognized database used to store document-oriented data. In this test, the environment is designed to mimic an environment where a handheld device with local data store that interacts with a server to sync data. The simplicity of using Zen is on both the handheld and server, while our competition requires a SQLite and Couchbase combination. In this case, Zen outperforms Couchbase by 5 times on insert, 2 times on delete and update. And since we are testing against Couchbase, we decide to include MongoDB too. In this case, since MongoDB has a mobile version, it is like Zen where both handheld and server have the same database engine. Once again, Zen is proven to be faster than MongoDB. Zen outperforms MongoDB by 6 times on insert, 2 times faster on querying of indexed data, and 8 times faster on querying of non-indexed data. 4 times faster on updates and 5 times faster in deletes. And all these benchmark papers are available at Actian Zen website. And finally, you might be asking now, is Zen used by customer in such IoT-ish environment? And the answer is yes. One such customer is Global Shop Solutions. Its ERP software enables manufacturer to deliver quality parts on time from quote to cash. It supports features like shop management, scheduling, inventory, accounting, quality control, CRM, and more. The challenges at Global Shop Solutions is how can they enhance and extend manufacturing ERP software for their customers' smart factory and Industry 4.0 initiatives. It needs the ability to deploy a small footprint IoT and embedded database that can run in a serviceless mode with just embedded libraries. This will enable customers to put inexpensive IoT-enabled devices into settings that used to require expensive PLC devices. The outcome with using Zen is only a single data management architecture to support their traditional ERP application and smart device application where local persisted data is required. The same data format and files are used across the device and the server, and that removes integration costs and improves security. Lastly, it is zero IT burden for the customers. What about customer outside of US? And the answer is yes again. The customer is Tsubaki Linksort in Japan. It manufactures automatic sorting machine that provides fast, quiet, and highly reliable sorting operations. Think of an Amazon distribution center. Boxes are being sorted to be sent to different trucks. Their challenge is these machines are required to sort 10,000 items per hour and with the ability to link this machine up to a series of 20. In such environments, several thousand database operations can be performed on each item sorted. Their solution is to use Zen. Zen is embedded in the registration and identification system of the material handling machines. Zen fast database operation enables sorting to be processed in time to meet the 10,000 items per hour operations, and Zen also provides the stability needed by these unmanned machines without a need for database administrator. Last but not the least, I present to you Actian Edge to Cloud solution. Zen purposefully built to meet your multi-access edge computing demands at column 1 and 2. And because the life journey of data does not end at column 2, Actian also supports you in your need to move data into the hyperscale cloud data warehouse. Your moving of data from the edge can be supported with Actian-built data movement products and lands directly into our Actian Avalanche hybrid cloud data warehouse for advanced analytical modeling. And I am really happy that you are here to learn. I encourage you to come test drive Zen and share your experiences. There are white papers, blogs on the topics that was covered in this session at our website. And it costs you nothing to test drive or even deploy your application using Zen Core. There will be 2 more Zen sessions following this session. So stay and learn more, especially from our Edge partner, Intel. With this, I thank you for taking the time to be here with us. Thank you.